All right, general chemistry. I hope you're doing well this week. This week, our goal is to look at titrations and figure out how to do a titration experiment and the calculations involved with that. So I want to show you first what a titration experiment has involved in it as far as glassware goes. In front of you right now, this is a burette. Let me scoot this down a little bit. This is a burette, and a burette is a glass device. It's just a measuring tube, basically, and I'll show you the whole thing here. It's a long, skinny tube, and on that tube, there's markings, just like a graduated cylinder would have, every 1/10 of a milliliter. And on the bottom of it, it comes to a little fine point here, and this burette is just a device to deliver a known amount of fluid. So I can open up the valve at the bottom. This is called the stopcock valve, and if you open it up, fluid will drip out of this, and you can very incrementally increase the amount of fluid that you add to something below it. So the burette, the whole goal of the burette is just to measure an added volume of solution. So if you fill this up, you would record an initial amount at the start of the experiment. You'd let some fluid out during the experiment, and then that would decrease your volume. And then wherever you stop at the bottom of that little meniscus, you would measure the final volume, and you'd subtract those two, and you'd have how much you added during the course of the experiment. So what do we add it to? Well, you would take an unknown solution. So that's the whole goal of a titration experiment. Your titration experiment starts with a burette that you would fill up with a solution with a known concentration. So we would put in this burette maybe a known concentration of sodium hydroxide, which would be a base. And then I would take an acid, an unknown acid solution, and that could be a solution collected from maybe an environmental application, or maybe it's something that was unlabeled in lab and you're trying to figure out what is the concentration of this solution. And you take that unknown acid and you put it in an Erlenmeyer flask. And Erlenmeyer flasks look like this. The reason you put it in an Erlenmeyer flask is because throughout the titration, you're going to be adding base. So I'll hold this up here. You'll put this underneath it on the ring stem. You'd open up the stopcock and you would add base to your Erlenmeyer flask down below it. And what that's going to do is it's going to neutralize the unknown acid solution. So as I add sodium hydroxide to my acid, it's going to neutralize it. And that neutralization reaction, you want to mix it. And so the Erlenmeyer flask is this shape so that you can swirl it and get that solution to mix really well. Before you go back under and add a little bit more, you'd swirl it. And you want to get perfectly at that neutralization point for the chemical reaction. And that occurs for a strong acid and strong base at a pH of 7. So one of the ways to measure that is to add in this unknown solution down here, add an indicator. And an indicator is a chemical compound that will change color when you get close to that pH of 7. And phenolphthalein is a good indicator that we use for strong acid, strong base titrations. It starts out clear, and as we get closer and closer to that pH of 7, the equivalence point is what we call it, the indicator is going to turn pink. And when it turns pink, I know to stop adding my base solution from my burette, and I know that I had exactly the right amount of base added to my unknown acid to reach equivalence. And that's how we're going to end up doing our calculations, using that value for the amount that we had to add from our burette to our unknown acid solution. Now you have to know whatever the volume is for the unknown acid that you start with, and we don't measure that in an Erlenmeyer flask. So before you fill this up with unknown, you would actually measure it in a graduated cylinder or using a pipette, a fixed volume, so maybe 25 milliliters, that's a common amount of unknown acid, and then you'd add that in here from the measuring device, and then you'd proceed forward with your titration experiment. So that's what the glassware looks like. That's what your experiment looks like. And I hope that gives you a little bit of a framework for what the diagrams are going to be depicting for our experiment and how they get used. I hope you have a good week this week. Ask me questions if you have any, and the next video that you'll be watching is basically how to do the calculations of a stoichiometry, or the calculations and stoichiometry of a titration experiment.